Hey, turn on your cameras, folks. Let me see all the dancing goofballs in the background of your place. All right, let's get down to business here. Let's get in our classroom with our apple and banana and all that, whatever we got in here. All right, enough of that stuff. All right, let's talk about, let's see, third day. So let's look at our curriculum because we start this week. We have an assignment this week already. I've already got the assignments. Remember, assignments come out on Mondays and they are there due for Sunday. So I'm going to bring your attention first off to our Google Classroom. You guys have already been this morning because you logged in here. Looking at Google Classroom, I want to point out that I've added now on the front page this blue icon down here, Buzz. So now this announcement here has, see the Home Access Center for your official grades. For class, use the link up here, which you all have done. You're here. For classwork, use the Buzz link. And then for flex or tutoring, flex time, if you need to meet with me, come to this link here. But the Buzz link is right here, which takes you to Buzz for our curriculum. So let me show you. I'll switch over. You need to make sure you can log into Buzz today. You got to make sure you can log in. So go to that link on the front of Google Classroom. And then once you have done that, your username, if you have not already logged into Buzz or used it last year, your username is that beginning part of your school email. Whatever that beginning part of your school email is your username. And then your password is online 2021. However, if you were in Buzz last year, it's possible your password that you had from then still works. It is possible. If it doesn't, try this. No spaces with a capital O, online 2021. So make sure you can get into Buzz today. Anyone who cannot get into Buzz, let me know and I'll have our Buzz Tech reset that for you to make sure you can get in. So you need to check on that today so you can get started with our algebra. All right, so I'm going to get off of that. Everybody see that? Okay, let me switch over and we're going to look at Buzz. I want to show you what we're looking at in here. All right, so when you log into Buzz, and it should be pulling up on your screen here very briefly. Let me go to the student app. Like ours is that green icon, Algebra 2. And when you click on that, it's going to take you to our Algebra 2 class in Buzz. And you will have this screen. You'll probably have that folder closed. So you have this screen, which right now there's not a whole lot in there. As we go throughout the year, we will add to that. It has this welcome information. If you want to look at any of that, it just talks about the course overview, those kind of things, getting started. Just has some basic information about Buzz and getting started Buzz. But all of our information is going to be here in Module 1. In Module 1 right here. So we do have a pretest for systems of equations. We have a lesson over solving systems of equations algebraically, followed by an assignment, and then a lesson on solving systems of equations graphically, which is easier, and an assignment with that. So today we're going to look at solving systems of equations algebraically. That's a little trickier, but we certainly need to do both ways. And then Thursday when we meet, we will look at the graphically portion of that. So we'll look at that. But while we're here, I want to just point out something you need to get familiar with. If you go up to the menu in the corner, this grade screen, or you can also click this icon right here to get to the grade screen. Either way, I'm going to click on the icon. This will show you all the assignments that you have, when they are due, what day you turned them in, if you've already turned them in, the little complete check mark, and what your score was. I just went through and I was just clicking answers to turn things in. So look at this. I did not do well in the pretest. Pretests don't count as part of anything. They're just testing to see what you know before you get into it. But solving systems of equations algebraically, see, I did not understand that. I need to go back and look at that lesson again. I need to redo that assignment. I did not understand it. But graphically, I did pretty well. I got 80%. So I may be happy with that. I need to go look and see what I missed for sure, because when I get to a quiz or a test, I want to make sure I score high. Remember our new grading scale this year, evidence of learning, quizzes, tests, etc. That's what counts towards your semester grade. Homework, practice, those grades do not count towards your semester grade. They're still assignments. These are homework practice assignments right here, but they are not considered evidence of learning that counts towards your semester grade. So you need to do these so that when we do have a quiz or a test, you understand it and you can do it well. So let me go back. Now go back to activities now that I've looked at the grade screen, understand it. And let's talk about solving systems of equations algebraically. When you get into that lesson, when you open that up, it will have, let's see how many pages. This one has 10 pages. 10 pages. So you want to go through these, and when you go through Buzz math lessons, for those of you who have not done this before, the first page is going to have the essential questions. You should be able to answer these two questions by the time you get to the end of the lesson, right? What methods can be used to solve a system of equations, and what type of solutions do the methods find, right? When I finished, this page doesn't have much. It has an introduction right here, and the questions. Click this next button up here, and that will take me to page 2. Now, usually there's a lot more information what you see. If we just scroll down, that doesn't look like much information. But when we look at this, we've got first, this talks about systems of equation, gives us some information that we need to read. Then it gives us an example. Solve the following system of equations using the elimination. All right. And then it gives 4 steps. And notice each of those highlight when I move my mouse over them. That means I need to click to see what's underneath there. Step 1. There's step 1 information. All right. Then I go to step 2. There's step 2 information. There's step 3 information. There's step 4 information. So there's a lot under step 4. So there's quite a bit of information on this page, just right here on the example. Down here is learn more. When I click on this link, it's going to pop up a window. And now again, here is another solve steps 1 through 4 with all this information. Now this has more information under the information. Check answer. It says, what could you multiply the first equation by to create opposite coefficients on x? Check your answer. So when you see a check your answer, if you're doing it on paper, great. Go ahead and work whatever the question is on paper first. Or if you're doing it in your head, have an answer before you click on check answer, because this just helps you know, did you understand what's asking? Could you answer the question? If you look at it before you come and answer in your head, you're not thinking, you're not learning anything. You don't know if you could do it or not. You don't know if you can do it or not. What else could you multiply the second equation by to create opposite coefficients on y? So you gotta get an answer in your head and check see if you're right. Oh, good. That's what I thought it was. So make sure you go through and do each of those steps on paper or in your head. Here's the nice thing. If you do this on paper and take notes, you can use your notes on the quizzes and tests in this class, right? Any notes you write down, have them in front of you on the tests. Use that. So I get through with page 2. I've read everything. I go to page 3 and so forth and so on, right? You go through all. Here's some real world productions. Here's a little scenario. And then you got to start writing the equation. What's the first equation for the scenario up here? And then once you type that in, you hit submit, it'll tell you if you're correct or not. So again, here's another opportunity to see, are you understanding what it's teaching you here? All right, then write an equation for a system. Here's another equation, the second equation. Submit, are you correct or not? Now here's the steps. Eliminate variable A or eliminate variable C, which one you want to do. There's different options. More real world applications, another pop-up box, more stuff there, right? So there's lots of information. It may look like there's just a little bit when you open a page, but you need to go through and look at the different things. Now in this lesson, I think we've got about 5 pages of actual lesson where it's giving us steps. It's teaching us how to do this. There's literal equations. This one has a video. That video is 2 minutes and 48 seconds. Another video down here. This one's 1.5 minutes, 138. Okay, so you go through these things. When we get to page 6, I think is when it starts giving us some practice problems. Oh, no, we got a little bit more here. All right, on page 6 is the lesson summary. Notice there's 10 pages. So after this, we've got several pages of practice problems to where you can go through and make sure you understand what you're doing. Here's the lesson summary. This is a great thing to either print off or make notes from. It's got a print button right there. You make notes from. This would be great for the test because this tells you the steps. To do substitution, step 1, step 2, step 3. Right? If we do general steps for elimination, step 1, step 2, step 3, step 4. Step 1, step 2, step 3, step 4. So this gives you all the steps right here and tells you what to do after you go through the whole lesson. And then, like I said, start on page 7, we'll have some practice. So this, it gives you 5 different equations. You come up with the answers, and then you have to match them. So like if you think this one goes with that one, you click that and that. Oh, that was not right. But if you click the correct 2, it'll disappear because you got the right ones matched up. Here's some more that you can try down here. 3 different problems you can try. More problems you can try here on page 8. All right. So there's different problems. So I'll tell you, the students I had last year that went through the lesson, tried the practice problems, and made sure they understand it here, had no problems when they got to assignments, quizzes, tests, at all, because there is plenty of practice built in here. Plenty of practice built in here. So the last page just tells you, okay, that's the end. Make sure you know the answers to those essential questions. Again, there's the 2 questions that were on page 1. And then you can go back and go to the assignment, which is right there. And the assignment is mostly multiple choice. It says I can retake it because I've already took it. I got a 0. This one has 5 questions that are multiple choice. So I can go through and I can retake it because I got a 0 the first time. So I need to go back and redo that. I'm going to leave right now and not do it right now. So that's what I want you to do on Buzz is go through, look at your lessons, and then do your assignments to make sure you understood the lesson. So today, I'm going to go through some of this with you on how to solve these systems of equations algebraically. So I'm going to do some examples together here in class, and that way kind of give you a preview. Generally, I will not go through and do the lesson with you each week. I'm not going to sit there and read the lesson to you. You have the lesson there in Buzz. I'm not going to read it to you. I'm not going to sit there and work through all the examples. I'm going to try to supplement that with additional stuff, working together live with you some things, or just giving you some different ideas or thoughts about it to help you understand it better. But I'm not going to just repeat everything you have in Buzz because that's wasting your time as well as mine. If you've already got all that in the lesson, I don't need to read it to you. Right? So let's look at, put this up on my screen before I forget to do that and start working without you. Let's look at a few systems of equations and look at methods of solving that algebraically. Okay, and we're going to look at 2 different methods here. We're going to look at elimination and we're going to look at substitution. So let's start with a very simple system right here. We've got x plus y equals 9 or x minus y equals 3. Okay, we should be able to find an x and a y that will make both of these true, the same x and y. We take the same x and substitute it in the same y and make both of these true. So we're going to do this by elimination. And the first thing we notice looking at this is we can eliminate the y if we add these together because they are opposite of each other. One is a positive y, one's a negative y. If I add these together, x plus x is 2x. Y minus y goes away. That's 0. So it equals 9 plus 3, 12. So 2x equals 12. Divided by 2. x equals 6. So we've already got one of our answers for this. X equals 6. I can take this and I can choose either one of these. I'm going to just choose the first one. 6 plus y equals 9. So if I subtract 6, y equals 3. So that is the solution to that systems of equation. If we put 6 in for x and y in for 3, both of these be true. 6 plus 3 equals 9, and 6 minus 3 equals 3. So that works for either one. All right, that is a very simple example of a system equation. Now let's make it just a little trickier. Let's do 3x plus y equals 7 and 5x plus 2y equals 9. Okay, a little trickier because first of all, if we add them together, nothing goes away. Nothing goes away. So we're going to have to manipulate one or the other to where we can make something go away when we add them together. So what we're going to do is we're going to take this first one. We can choose either one. We have lots of options here. I see I have a y and I have a 2y. So since this is a 2y, if this was a negative 2y, it would go away, right? Because that would make that 0 if I add them together. So if I take this entire equation and multiply it by negative 2, that will cause it to go away when I add them together. So I'm going to take negative 2 times 3x, and that's negative 6x. Negative 2 times y makes it negative 2y, which is what I wanted. Negative 2 times 7 is negative 14. All right, so now I can add those two together. I've taken the first one, I multiplied the entire equation by negative 2. That should not change the variable because I've multiplied both sides. I multiplied everything by negative 2, so the variables should still be the same variables. So now adding these two together, 5x minus 6x, that's negative 1x. 2y minus 2y, that goes away, that's 0. 9 minus 14 is negative 5. So since negative x equals negative 5, I divide by negative 1, x equals 5. There's one of our answers. Now we can go back and substitute it in either one of the original equations. It'll also work in the one we change, but let's choose an original equation. So let's choose the first one again, just because. Okay, so 3 times 5, since we know what x is, plus y equals 7. 15 plus y equals 7. Subtract 15, y equals negative 8. Y equals negative 8. We can check that in the second one just to make sure. 5 times 5 plus 2 times negative 8 equals 9. 5 times 5 is 25. 2 times negative 8 is negative 16. Does 25 minus 16 equal 9? Absolutely. 9 equals 9. So this does work in both equations. All right, let me give you another example. Something else to kind of raise the level just a little bit more. Throw a little bit of a curveball at you. And now let's say if we have x plus 2y equals 6. Okay? If I add those together, nothing goes away, right? This is the process of elimination. I'm trying to eliminate one of the variables where I've only got one variable. So right now, if I eliminate, nothing happens because it won't eliminate. So I need to manipulate, again, change this. So let's just change the second one. If I have 4x, let's make this a negative 4x. So I want to take this one. You can add to make one equation, but you still can't solve it. If you don't eliminate an x or a y, 5x plus 10y equals 26, we still don't know how to find an x or y. We're trying to figure out how to solve and find what x and y is. Because there still could be a whole lot of different x's and y's. I mean, let's look at that real quick. 5x plus 10y equals 26. There's multiple x's and y's. If I change this x, I can change that y and come up with 26. If I change it again with positive and negative numbers, with fractions, there's all kinds of different, there's an infinite number of x's and y's that I could put in there to equal 26, especially if I'm using fractions and negative numbers. But there's only one x and y, perhaps. We're trying to figure out what is the x and y that would be true for both of these, this and this, because that narrows it down. 5 and negative 8 is the only thing that would be true for both of these. I can find a lot of x's and y's. There's a lot of x's and y's for 3x plus y, because if x is 1, then y could be 4, and it would be 7. But if I move down here, 5 times 1 is 5, and this is 4, that'd be 8. 5 plus 8 does not equal 9. So I can find lots of them that will work in one equation, but not the other. But I need to find the solution that works in both equations together. So that's what I'm trying to do, is find one x and y that would work for both of these. So if I multiply this by negative 4, now I've got negative 4x, negative 8y, and equals negative 24. Okay, so I've just replaced it with it. So I'm adding these two together now, because I've taken this one and changed it. So 4x minus 4x, that went away. 8y minus 8, oh, that also went away. 20 minus 24, that did not go away. What we have is we have a statement that says 0 equals negative 4. Does 0 equal negative 4? Does 0 ever equal negative 4? There's no variable in there. Nothing changes. Changing x and y doesn't do anything because there's no x or y. This is not true. And since that's not true, there is no solution. There is not an x or a y that would work in both equations. It would take a different x and y to make those both of those true. There's not one, because we ended up with a statement that is false. Now, it's also possible, had this been, let's say instead of 20, maybe this was 24. Then when I have 24 minus 24, this would be 0, and we would have 0 equals 0. This is a true statement. 0 always equals itself. So in that case, we have an infinite number of solutions. It means there's a lot of x's and y's. There's an infinite number of x's and y's that we could do to make them true. There's not just one true answer. There's an infinite number of answers. And it's not just any x or y, but there's an infinite number of specific x's and y's that would be true. So if 0 equals, if we end up with a true statement, if it's 6 equals 6, or 11 equals 11, any true statement, that means there's an infinite number of solutions. But any untrue statement means there's no solution. No solution at all. Okay, let's look at another method. Elimination is one that is very popular and is used a lot, but let's look at substitution, because some people like substitution better. I like substitution. It can work depending on the equation. Math has a lot of different ways to solve equations. There's often not just one way to do math. So this is one of those definite cases where you can choose how you want to solve the problem. Okay, so here we have another set of a system of equations, these two equations. We could do it by elimination. We could multiply this by negative 2 if we wanted to make that a positive 2x, or we could multiply this by a negative 1/2 to make it a positive 1x. And so, I mean, there's lots of different things that we can choose however we want, but I'm going to do this substitution method. So I'm going to take this equation over here and I'm going to solve it for x. Negative x plus 3y equals negative 3. So I'm going to solve it for x. So it means I'm going to move the y to the other side. So over here I've got negative x equals. Now this is a negative 3y and that's a negative 3. Those are not the same thing. I cannot combine them. That's a constant. That has a variable. That's a coefficient with a variable. So when I subtract 3y, it's just minus 3y minus 3. Now, this is not what x equals. This is what negative x equals. I've got to divide everything by negative 1. So x equals positive 3y, positive 3. This is what x equals. Now, we don't have a number for x yet, but we will get there. But what I want to know is, what is x equal in this equation? So since I used the second equation, let me highlight this. I used this equation, right? That's the one I got to get x. So since I did that, I have to put this back into the other equation. I can't put it back in the same equation that I created it from. So if I take this equation, negative 2, and instead of putting x, I'm going to put what x equals. This is what x is, parentheses, 3y plus 3 minus 2y equals 26. Oh, look what we've done. We only have one variable now. We have a y. We have it twice, but that's all we have is one variable. So we can solve this for y now, and that will give us one of our answers. So let's distribute, right? When we have parentheses, we've got to multiply this by everything inside the parentheses. Negative 2 times 3y is negative 6y. Negative 2 times 3 is negative 6. Minus 2y equals 26. Okay. We have negative 6y minus another 2y. We have negative 8y minus 6 equals 26. Okay, we're trying to solve for y, so let's move the 6 to the other side. It does not have a y attached to it. So negative 8y equals 32. Divided by negative 8. So y equals negative 4. Now that we know that y equals negative 4, we can take that back up and substitute it into the other equation. Negative x plus 3 times negative 4 equals negative 3. We're going to give it x. X could also, we could put it right there because we know what x equals. But I'm going to put in this other equation. So negative x, 3 times negative 4 is negative 12 equals negative 3. Add 12 to move that to the other side. So I've got negative x equals 9. So x equals negative 9. So I've got y equals negative 4, x equals negative 9. We could also check it there. 3 times negative 9. Oh, well, that's just what x equals. It doesn't tell the number. So let's see, plus 3. I can do that because what x equals. 3 times negative 9. Oh, I'm sorry. We have to put the y in there. That's not what x. That's not what y equals. That's what x equals. 3 times negative 4. I'm sorry. 3 times negative 4 plus 3. 3 times negative 4 is negative 12 plus 3. Again, x equals negative 9. So we can also figure out what x equals right there by substituting the y in for that negative 4. So this is using substitution. We can substitute. We can solve one of these for x or y. We could have solved that for y if we wanted to, but we would end up with a fraction for the x number. It'd be like 1/3 x, which you can do if you're comfortable with fractions. You can put the 1/3 in there. But I try to find something which is like a solo variable. We had a negative 1x that we were able to figure out what x equaled. This one we could have done also because we could divide by 2, and everything divides by 2, so we would not have had a fraction in there, and that gives us options as well. So I'm going to show you one more example. And again, when you go through the lesson, you will get these steps. So I'm throwing a lot at you right here kind of quickly. But when you go through this lesson, it's going to take it step by step. And so you get to try this step and put the answer in. It'll tell you if you're right. Try this step, put the answer in, tell you if you're right. But I'm going to take it one more step up because in your practice work, you'll have one similar to this. In fact, this one I took exactly from one of your practice of the lesson. It wasn't from the assignment practice. It's from the lesson. So I will, you'll see this one again, that working through the steps. You'll notice right off, you have three variables here. This is a z, x, y, and z. Since we have three variables, we're going to have three equations. You're like, oh my goodness, here I'm still trying to figure out what you're doing, two equations. And now you're throwing three equations at me? Yeah, I'm afraid so. Three equations, because we get to that in this lesson. So I can do elimination or I can do substitution, either one. And the way we do it is we break it out into just two of them. We'll pick two of them and work with them that way if we're doing elimination. And we try to eliminate one variable to where we just have two variables and two equations and then solve it the way we know. But I'm going to go ahead and do this one by substitution. If I look at it, I see right away that this is a good candidate right here. Here's just a z by itself. So if I solve this for z, let's pull this one out. 2x minus 3y plus z equals -4. I'm going to solve this for z. So I'm going to move these to the other side. -2x plus 3y, right? -2x plus 3y. And so they'll go away over here, right? I've just subtracted 2x from 2x and I add 3y to -3y. So all I have left is a z. Z equals. So I was trying to get the z by itself. On the other side now, I moved the -2x, the plus 3y, and we had a -4 over there. So all I did is I took this and moved it to that side to get z equals. Z equals -2x plus 3y minus 4. So now that I have that, I'm going to, now I can't do it in the second equation because that's how I created it. So I'm going to take it and put it in the first equation, and I'm going to put it in the third equation. I'm going to choose the other two equations that I didn't use to substitute z in there. So let's take this first one, 4x plus y minus 2, but instead of z, I'm going to put what z is equal to. Z is equal to -2x plus 3y minus 4. And all of that equals -13. That's what z equaled. I substituted it in for z. So now let's simplify. 4x plus y minus, now we have to distribute. And again, remember, we have to distribute to everything inside the parentheses. So that -2 is being multiplied by every term inside there. So -2 times a -2x is a plus 4x. -2 times 3y is a -6y. -2 times -4 is a positive 8. Okay, so now I look and I have some like terms. We have a 4x and a 4x, and we have a y and a -6y. So we have like terms, so we can combine those. 4x plus 4x is 8x. Y minus 6y is minus 5y. And then we have that plus 8 equals -13. Let's move the 8 over there. So we have 8x minus 5y. We subtract 8 from both sides. Equals -21. So we have taken this equation and we've eliminated one variable, and we have it down to just a simple variable like we were doing on the other page, right? Like we were doing over here when we had just two variables and two equations. We've done the same thing here. So that was into the first one. Let's do the second one the same way. I'm going to stop right there. I'm going to circle that. I don't want to lose it because I'm going to need it here in a minute. 4x minus 2y plus 3 times, and what is z? Z equals -2x plus 3y minus 4. equals -1. So I just want to highlight that so we know where that came from. This is what z equaled, so we substituted in for z, and we substituted in for z where those two z's were in those other equations. We took it because I'm going to highlight the z equals also. Now let's simplify again. Remember, distribute to all three. So we got 4x minus 2y plus 3 times -2x, -6x. 3 times 3y, 9y. 3 times -4. Okay. Now again, we have like terms. We have a 4x and a -6x. We have a -2y and a positive 9y. So we can combine like terms. 4x minus 6x, -2x. -2y plus a 9y is plus 7y minus 12 equals -1. Add 12. So now we've got -2x plus 7y equals an 11. So we've again eliminated the z in the other two equations. So now we can take those and do what we were doing before. And here's our other one, -2x plus 7y equals 11. Again, we have choices. We can do elimination if we like, or we can do substitution. Either way. I see an 8x and a -2x, so that really makes me want to use elimination. If I just multiply this by 4, it will disappear. So 4 times that is -8x. 4 times 7y is 28y. And 4 times 11 is 44. All right. I can go ahead and write this one down here so I don't get confused. That's probably not a bad practice to get into, because this is what I'm adding together is these two. The first one and the second one after it was changed. So when I add those together, -8x and 8x goes away. 28y and -5y is 23y. 44 minus 21 is 23. Hey, that worked out really nicely. Divide both sides by 23. Y equals 1. Okay, we're getting closer. We've got one of our three answers. Let's take that, choose one of these two. Let's just pick that one. -2x plus 7 times y equals 1 equals 11. -2x plus 7 equals 11. Subtract 7. -2x equals 4. X equals -2. We're getting so close. We now know, if we go back to our three original equations, I'm going to copy one of them down here. Okay, 2x. So I'm going to put 2, but instead of x, we know what x equals. -2. Minus 3y, minus 3, but we know what y equals. Plus z equals -4. So there it is, substituting y equals 1 for the 1 and substituting x equals -2 for the -2 right there. 2 times -2 is -4. Minus 3 times 1 is -3. Plus z equals -4. -4 minus 3 more is -7. Plus z equals -4. Add 7 to both sides. Z equals -4 plus 7 are 3. So x equals -2, y equals 1, z equals 3. And if we use those numbers and substitute them in all three of these equations, all three of those equations will be true. This will equal -13. This will equal -4. This will equal -1 if we use this x, y, and z. So that's why we call it a solution to a system of equations. That same solution will work with every equation in the system. Every one of them will work with that X, Y, and Z. So now you're going, wow, that took the whole page for one problem. Welcome to Algebra 2. Sometimes it gets that way. It's the little details. So you got to pay attention, go through the steps carefully, because if we'd have missed a minus somewhere along the way, we're going to get to the end and things are going to start falling apart. But that's okay. You just take care of it one step at a time. One step at a time. That's all we can do in this. Now, that problem there that we just did, that big long one, is actually in your lesson. So when you get there in the practice problems, you'll have that one in there, and it will walk you through step by step by step. And you can click on the little highlighted box and it will pop open, and you can look at each individual step one by one. But I would encourage you to try to do it on your own first. When you see that step one, try to do step one on the paper and then click and check, see if you're right. You're going to learn so much more than just, oh, let me copy that down. You're not thinking if you're copying down. You're thinking if you're trying to do it yourself and then double checking it. And you can see if you don't have the same answer, where did you do something different, right? So remember, there's more than one way to do it. We looked at two different ways to solve right here, elimination or substitution. And even on elimination, we could eliminate the X or we could eliminate the Y. Or we can eliminate the Z when we get to that option with three of them, right? So lots of different ways to solve these systems of equations. And we looked at two of them today. Thursday, we're going to look at solving by graphing, which you're really going to like because it doesn't require a whole page of paper. Solving by graphing is nice, but we don't always have that option. We do need to know how to do it algebraically. We need to know how to do it either by elimination or by substitution, but we will learn graphing on Thursday. You have the lessons now. If you can't log into Buzz, let me know. All right. Because I need to get that fixed where you have access to these. This is due. You have two lessons that are due in that pretest. The pretest just to see what you know ahead of time that are due Sunday. So now, do you have any questions after I threw all of that at you? And if you didn't understand it all, that's okay. You haven't read the lesson yet. You haven't gone through it. Like I said, the lesson's going to show you one step at a time, and it'll let you try that. You try a step. Did I get the right? Okay, what's the next step? Okay, let me try that. Did I get that right? Okay. So it's going to walk you through it slower. I've got this recorded. You can come back and look at this later if you need a refresher, but go through the lesson first, step by step. So again, any questions? You open the chat, make sure I'm not missing anything. Can I show the paper again? Yes, you want the last one, the big one with all of the, I could probably show it all at one time. Should be pulling up on your screen now.